Welcome, ladies and gentlemen, to another coding session on YouTube on Binary Life. Binary Life is a channel that helps developers um, learn how to code better, and we do coding algorithms so that you can see the thinking process and how it's done. Now, on this special edition, instead of doing live coding like I've done for the other challenges, I am going to actually do a walkthrough of a solution that I have already done, so that you instead get the logic instead of getting the code. And as for the code, you can get it on the GitHub link that I'm going to link into the description below. So today we're going to be solving the Roman numeral encoder, which is changing a number into the Roman numeral representation. Now I notice 24,000 people have attempted this and just 7,000 have succeeded. So I decided to code and instead do a walkthrough because people are having difficulties in achieving, and you are going to get the logic behind my code. Now this is the references, as we can see here, of Roman numeral to decimal equivalence. So 100 is a C and 500 is a D. Now in order to achieve this solution, I actually solved it in a separate file. And the file is made up of 3 utility functions. This is the first one, this is the second one, and this is the third function. And I've used all of them into solution. The function solution is the function provided by the codewars editor. And I'm going to do a walkthrough of each function so that you can get the logic behind it, and you have a sense of how I approach this problem. So let's start with the very first function. The very first function is a function that breaks down the number given into segments of multiples of 10s. For example, I have comments above each function. If I have a number like 1235, that number is made up of 4 segments. According to this function, we have 1000, we have 200, we have 30, we have 5. I think you can get the logic. Now let's copy the function, and I'm going to go into a blank browser tab, and I'll run it into the console portion. And now let's execute this function with the test number. Remember, I send in the number as a string. So if I run it with 456, it returns an array of inside this number. We have 400, we have 50, and we have 6. Now what is the utility of running that? It's because I can loop through these segments and get exactly and go into the original Roman segment and extract. Like here we have 50, and 50 is one of the numbers having a letter in Roman representation. So I'm breaking it down into segments so that I can have a vision of which parts can be extracted directly. Now here we have 50, but we don't have 400, and we don't have 6, which means this has to be computed because they are eventually made up of a combination of other Roman numerals. So that's the use of the very first function. The second function is to test if a given number string is a multiple of one of the reference numbers. Now let's run this code so that you can get an idea of how it runs. I think you can already have an idea. Like if we have I have a comment section above this function. If we are given a number like 20, we can see that 20 is a multiple of one of the reference Roman numeral. One of the reference Roman numeral is 10, so 20 is a multiple of 10. So this function returns an object. I decided to return an object so that I can pass in 2 very important simultaneous two very important answers. Like I have is multiple, it returns true. That's the first part of the object, and the second part is an array showing how many times that multiple appear. Like 20 is 10 two times, that's why I return an array of 10. If it is not a multiple, it's going to return false and an empty array. So let's just test that and we'll see what I'm talking about. So I'm going to right click and clear the console and clear the history. Now our function takes as input a number and a reference array. The reference array is something like this. It's just made up of an array having the reference Roman numerals. All right, that's a constant. So if I run this function, with 90 and passing the reference, I get a true, because 90 is a multiple of 10, so I get a true. Is an object with two parts. The first part is true and the second part is 10 9 times. If I run this with 20, I get a true. We have 10, which is a multiple of 2. We have 20, which is a multiple of 10, sorry. And so 10 appears 2 times because we need 10 2 times to have a 20. That is a reference to that. That is the role of this second function. Now you are going to see the use of it as we use it into the third function, which is actually the most important and cumbersome function. I think this is the heart of the algorithm here, so pay particular attention. So I call this Bale order numbers because it's easy to have segments here and it's easy to have multiples here, but generally the numbers will be a combination of multiple Roman numerals, so they need to be computed. For example, 13 is x and ones, 7 is v for 5 and ones, 8 is v and ones, and 27 is x and v and ones, and you get the logic. So this function also uses a number that I pass as a string, and it does the computation to determine these segments here. Now I'm going to do a rapid walkthrough of this algorithm so that you can get the logic. The first part is to check if the number passed is less than 4. For example, if we have a 2, it's just 2 strokes, so we just insert 1 twice. Now before I come back to this algorithm, I want to go to the solution, the initial algorithm, so that you can see the use of why I'm pushing these ones. At the end of the day, all the breakdowns I'm doing is because I have created for myself an object called symbol object, an object made up of symbols that have a matching between the decimal number and your Roman equivalents. So these are the base Roman numerals and the Roman equivalents: 0, 1, 5, 10, 50, 100, 500, and 1000. Now there is something particular about 4, 9, 40, 90, 400, and 900. You can see the reference, that is 4 and 9, 4, 9, 4, 9. Now if we go to the challenge, there is a Wikipedia link that has some documentation regarding Roman numerals. So if we go to that Wikipedia link, somewhere in the middle there is a text that talks about the 4 and 9 here, using something called the subtracted form. So 4 and 9 are written as subtracted notation. What does that mean? It means this is 4, this is 1, and 5 is like 5 minus 1 read backward, something like that. 9 is 10 minus 1. if we didn't do this, 4 would have been written like this, like one stroke 4 times. So this is the particularity for 4 and 9, 40 and 90, as well as 400 and 900. Now the text says these are the only subtractive forms in standard use. So with this confirmation being the only subtractive forms, I decided to add it. Let's go back to my file. Sorry, I decided to add it into my symbol collection. So at the end of the day, I'm breaking down these numbers into segments and multiples, so that at the end of the day I will just come and look up into the symbol object and grasp the equivalence. So let's go back to where I ended before. Firstly, I broke down into segments. That's the first function. This one checks if they are multiples of one of the reference numbers. And this is the third function, where we are building and breaking down other numbers that are made up of a combination of all the Roman numerals. So if the number is less than 4, it means for the case of 2, we have 1 2 times. If it's 3, we have 1 3 times. So I just push into this array. Once. That's simple. And then at the end, I return the array. In the other case, if it is not less than 4, like for example 6, if the number is 6, I'm going to check if the number is a multiple of one of the reference numbers. This function, I explained it before. Now I said the function returns an object with 2 parts. First, it checks if it's multiple. The first part is multiple. It returns true or false if it's a multiple, and then the second part is an array. So I'm going to check if the array length is less than 3. Let's go back to the exercise. It says remember that there can't be more than 3 identical symbols. Let's go back to the browser. When we were checking if it's multiple of reference number for 90, if 90 is a multiple, we return a true. We have 10 that appears 9 times, but that doesn't mean we should write now what is 10 for the Roman numeral? That is x. That doesn't mean we should, for 90 we should write x 9 times. This was just to check if it's a multiple, and it said we can't have three repetition, and for this case we have 9 of them, so it doesn't work. That is why for this function I'm checking if the length of that array, that second part, is less than or equal to 3. If that's the case, I'm going to push the array part into our array here. Now for the case of 90, 90 is not a good example. Let's take for the case of let's say 25. Oh, not very important. Basically just retain that if we have a repetition of more than 3, then we won't enter this loop. We're actually going to go into the computation to compute. Like for the case of 8, for example, this is 8. 8 is made up of v, which is 5, and 1 3 times. So it won't enter this first part because 8 is not less than 4, and it won't enter this part because 8 is not a multiple of one of the reference Roman numerals. So it's going to enter this while loop. So what are we going to do? What happens is that we're going to take the number. This is the number that was passed in the form of a string. We put it inside the number. I put a plus, that's I convert it back into a number, and then I'm going to loop through this reference array here. This is it, the loop. and I'm going to check which number is very closer to 8, like which number plus 1, the previous one, is greater than 8. Oh, sorry. Now for this case, as we are going progressively, the number greater than 8 is 10, which means 8 will be a combination of 5 and lower numbers. So what am I going to do? I am going to have checked in order to fix the reference number. So I'm going to take the number and divide by the reference number. Now the reference number at the position I, remember we stopped at 5 for 8, so we're going to take 8 and divide by 5 because we want to get the remainder. So 8 is made up of 5 and 1s. So that is what this if loop was about. So we got 5, so we're going to push 5 into our array. Now we are going to do the division to get the remainder. It's left with 3. And for the case of 3, we're still going to check if the number is a multiple. Now this particular scenario is important for a number like 25. Well, let's just forget about that example. Now this is the computation. I take a number, I check into the reference array which of the number is closer to it. For the case of 8, we have 5. 10 is very big, so 5 is the next. 5 is one of the biggest number that will make up the 8. So I take 5, I push into my array, and then I take the remainder, which is 3. I store it back into number, and I check if the number is a multiple. If that 3 is a multiple of one of the reference number, it's not the case. So I check also if the 3 is less than 4. If it's less than 4, then I'm going to push once. That is why I'm going to have a 5, a 1, 1, and 1. So that is how the whole of this construction take place. And then I'm going to break out of the loop. There is no need to do that. That's it. That's for these 3 functions. And I use all of these functions into the solution algorithm. Now, how do they line up? Firstly, I explain to you this collection of symbols. So in the beginning of the algorithm, I break down into segments. I collect it into an array called segment. Here is it. And then this is my Roman construct, which is like an array, which is like it's a string. Actually, it's an empty string. It's going to have I'm going to be constructing the Roman numerals as I go through the segments. So I loop through the segments, and I'm going to check if after breaking into segment, the segment is part of the symbol, these symbols here. If it is there, I'll collect the symbol and concatenate inside my Roman construction. If it is not part of it, it means it needs some computation, which is going to come from one of the functions above, which is the VIII other numbers. And don't forget, VIII other numbers makes use of checking of the multiples. So this is the whole computation here taking place. As it does that, it collects the number. All those, remember, all those functions return arrays. This, after breaking down into segments, return the segments in the form of an array. And this one, after checking if they are multiples, return an object that has an array portion. That I'm going to use. And then this one that does the computation for the other numbers made up of a mixture of Roman numerals also returns an array. At the end of the day, all these arrays is broken down to be elements of these symbols at the end of the day. So that is why when I break down the numbers, I collect it into a temporary, that's why I call a temporary segment, and then I loop through the temporary segment, that's why I call mini segments, and I collect the symbols of those segments. I concatenate it into the construct. At the end of the day, I have a final construct that I can return. So that is the logic behind this algorithm. Now if I copy all of that code into my codewars, I can replace this one. It passes the test and I can execute it. Now everything is passed. So this would be some huge brainstorming if I had to be coding live. That is why I prefer to explain to you the logic and the breakdown of the individual functions that make up this algorithm, and then you can grab the code on GitHub and spend some time to understand it. So somebody has done something easier. This is great. And mine was broken down into very simple similar steps, and I hope it helped you to understand. And see you for another solution. This one is very long, crazy. See you for another solution for another algorithm. Don't forget to subscribe for more algorithm challenges, and thank you for viewing.